All right. Hello, P-Way Class of 2020. This is going to be one of the last few videos I'll make for you. So I wanted to make sure I mentioned one of the most favorite topics I do at the end of the year. You see these formulas on physics worksheets, and I just wanted you to really appreciate where they come from. The first thing is you've heard the word position, basically the distance something has gone or where it is compared to where it started. So sometimes there's an S, sometimes there's an X. Velocity mostly is a V. Acceleration, we can use A, some people use G for acceleration due to gravity, but I will note that in these formulas, this A is a negative number and the G is a positive number, just the way they wrote the formulas. But if you really look carefully, they are the same exact formulas, just using different letters. So, after 2,000 years of struggling to understand the mechanics of falling objects, I feel like we can now take everything that's been studied from Aristotle to Galileo and really just put it into a nice little summation of where these formulas come from. All right, so here we go. Let's start with acceleration. Now, if you start with acceleration and understand that acceleration is the antiderivative of velocity. So you basically took the derivative of velocity with respect to time. Now, in our book, I believe they use negative g, which is a constant. Okay, g is a number. I guess we can say it's any real number at this point. No, but greater than 0. So there's acceleration. So if I wanted to go backwards and look at velocity, velocity would be the antiderivative of acceleration, which basically means it's the antiderivative of acceleration, the negative g, which is a number. And it was in terms of the velocity with respect to time, because you always do need the labels there. So when you're integrating velocity, it's velocity with respect to time and the antiderivative of the number negative g. So if we keep going here, velocity is the antiderivative of a number. So that number can come out, negative g, but remember you still need the variable because it was antiderivative. So if you were doing derivative of gt with respect to t, or if you were doing the derivative of negative gt with respect to t, its derivative would be negative g, which is right here. So the antiderivative of negative g is negative gt. Do not forget, plus some constant, right? You're going to need some constant there. Now, that constant we can say is c, or we could then basically come up with the formula you see in front of you. Velocity is negative gt, and instead of c, we can say initial velocity. So that basically gets you your velocity formula that you would have used in physics class. Now, if we take that velocity formula, let's pick color, new color, and we go to position. Okay, position like your distance basically. The position is the antiderivative of velocity. So in this case, that would be the antiderivative of negative gt plus initial velocity and position. So you're integrating velocity, which was distance with respect to time. So as we do the antiderivative of that, position is the antiderivative of negative gt. So negative g comes out, it's a number, and the antiderivative of t would be t to the add 1 and times by 1 over that number. So that's really the, getting good in integration is what I really want us to be able to leave for the year doing, at least the beginning parts of it. And everything we did up to the SGO, honestly, was a good intro to calc, limits, derivatives, but the real bulk of it starts with antiderivatives, integration. So you really want to see as much of this as you can now because it will help you move on to higher level topics. So as we integrated negative gt, we got negative g times 1/2 t squared, because the derivative of this would be negative gt. All right, so the antiderivative of the initial velocity, since that's a number, should be that number times the variable t, which is what we were doing it with respect to. And then you have your own constant. This is some other constant. So basically, position, which sometimes we use s for position, right, is, if you clean this up, negative g over 2t squared plus v naught t plus c. And so there you're getting your position formula that you will see in a lot of different applications. So good luck applying these, and I can't wait to hear how things go for you as you continue out of high school. And I look forward to you always emailing me, reaching out, and let me know how you're doing.